Hi, today our team Information Retrieval and Extraction will be presenting our project on data augmentation for information retrieval. Information retrieval is the process of querying a large amount of data and retrieving the relevant answers for the query. This entire pipeline is composed of two main stages. We first fetch an initial list of documents and then re-rank them according to their relevance. One approach that has been widely used to implement information retrieval is BM25. BM25 is a bag of words retrieval function that ranks a set of documents based on the frequency of appearance of query terms in each document. However, since the model heavily relies on word overlap, this significantly affects the performance of the model due to mismatch between the document and query terms, especially in the case of rare words. This results in the vocabulary gap problem. The performance of information retrievers can be significantly improved using recent representation learning approaches like neural networks. While using neural networks can help learn better representations, these models often require larger training data sets to better learn representations and to avoid overfitting. However, the size of the training data set is often limited and is a significant drawback of neural network-based approaches. In this project, we aim to explore data augmentation techniques to overcome the limitation imposed by the limited size of the training data. This could possibly benefit multiple neural network-based retrieval models. These techniques could include random or rule-based augmentation techniques and even model-based techniques. Some data augmentation techniques include random insertion, synonym replacement, and masking and model-based synthesis. We aim to apply these techniques both to the query and to the document while training. So like either applying them just to the query or just to the document or a combination. Previous research has shown that utilizing these data augmentation techniques for the documents and for the queries could lead to significant improvements in model performance. This is one of those papers where they've done such data augmentation. We hypothesize that utilizing a combination of various data augmentation and query reformulation techniques might further boost performance of information retrieval models. To test our hypotheses, we would compare the performance of the model on information retrieval tasks on datasets such as Cranfield and MS Marco. We would use metrics like mean reciprocal rank and mean average precision to evaluate the model performance. Our main goal is to improve the information retrieval training pipeline in the FlexNewArt framework by introducing data augmentation and query reformulation techniques. We aim to develop a plugin module to implement these techniques. The modular architecture will provide flexibility to users and it will allow users to experiment with different data augmentation techniques or a combination of those techniques.
We want our data augmentation techniques to be present as an open source library that can be plugged into information retrieval frameworks like FlexNewArt. This way they can be used and accessed by everyone. Researchers working in information retrieval can plug our module for improved training and benchmarking of multiple tasks. Businesses that use IR frameworks for their use case can add and experiment with these various options and that we would provide and see what fits their needs the best. Additionally, newcomers in NLP could also try out our code and draw insights, since this will be publicly available as an easy to install library and use it with different IR frameworks. We intend to deploy an independent module with multiple data augmentation and query reformulation techniques, and we will broadly classify them as simple rule-based and model-based techniques. These will be discussed in detail in our design models. We will also be developing a parallel support for integration into existing IR frameworks and provide end-to-end training and testing pipeline. For our development work, we will be focusing on the FlexNewArt framework. This is a rough diagram of how we would want our data augmentation module to incorporate into an IR framework. Coming to the non-functional requirements, we will ensure interoperability by developing a library that will be pip installable and thus easy to integrate and train. Our code would be modular and encapsulated in functions that can be easily unit tested and integrated with frameworks. Our code would be robust and well documented for ease of use without having to go into code level details. We would also make sure that including the data augmentation doesn't become a bottleneck in the training pipeline and add necessary optimizations. For the resource requirements, the non-development requirements, we need a thorough literature survey for relevant data augmentation and query reformulation techniques that can be implemented in IR, and decide on the baselines to use for our experiment. This phase has already been completed. We plan to use two data sets in our project, Cranfield and MS Marco. We need to obtain these and pre-process it according to our requirements. We are currently working on a subset of the MS Marco for our initial tests. Under hardware requirements, we will be needing GPUs to efficiently train our BERT-based retriever and ranker models, and we would also need storage to save the large data sets we will be working with. Next, we see some of the design considerations in our project. We assume that our data sets follow Zipf's law and Heap's law, which are used for defining corpus level statistics in NLP. We would also assume that the augmentation techniques that modify the documents and queries would not change the true label of the data. Some neural network based augmentation techniques require end-to-end training of the retriever and re-ranker models, which can be computationally very expensive and would not be considered. We also avoid choosing too large a data set due to limited processing power and in-memory storage. The model will be run in Python system environment, and we will make the system open source and portable to all machines. And as mentioned before, our design methodology would be to have an open source pluggable module that implements various data augmentation techniques. Also, some of the methods that we plan to try out would modify the query as well instead of just the document in our IR pipeline.
Hi everyone. So I'll be explaining the system architecture and the design overview for our system. So as mentioned before, the goal of this capstone is to better the re-ranking of the documents. So firstly, we have in our data a query and an index document collection. And then the query is passed through a retriever. The retriever will go and fetch documents which are relevant from the index document collection and will generate an initial ranked list of documents. And now what we will be doing is creating this data augmentation module, and the initial ranked list of documents will be passed through the data augmentation module, which will augment the documents and perform some augmentation techniques on it. Also, we will be passing the query through the data augmentation module as well. So we have augmented documents as well as augmented queries. And finally, these two things are passed through the re-ranker module, and the re-ranker module will get the final list of top K documents. So this is our entire system architecture and the pipeline of how things will work. Next, we talk about data design. So as Shayoni mentioned before, right now we are using a subset of MS Marco for our initial set of experiments, but you can see that we will actually be using two data sets, Cranfield and MS Marco. So Cranfield is a small data set, as you can see from the number of documents and queries, whereas MS Marco is quite huge. And so currently we are using a subset of it. In the data flow diagram as well, you can see the data is passing from the data set to through the retriever to the data augmentation module, and finally to the re-ranker, as mentioned before in the system architecture. Next, we talk about implementation overview. So we have our document and query, and these are the techniques that we will be using. You can see that for the documents, we will be using either rule-based or model-based or a combination of them for the augmented document. And the query can be passed through rule-based, model-based, as well as query reformulation, or any combination of these to get the augmented query. And this is the data augmentation module that we will be designing. So now coming to the actual design models that we will be using, the techniques of data augmentation that we will be implementing. So the first technique is rule-based techniques, which actually use the rules of language and try to exploit these rules to get better augmented documents, as you can see from this example. I'll be explaining more examples in the next slide. So here in this slide, you can see there are, for the rule-based techniques, there are easy data augmentations, such as insertions, deletions, replacement of words, or swapping, and or replacements and things like that. We also have some more complicated techniques such as hypernym replacement and synonym replacement and things like that. So on the right, you can see that in this diagram, you have the initial original document on the left, and in the middle, we have the technique that we will be applying. And on the right, you have the augmented document. So first, you can see that in the first document, the word sad is replaced by lamentable, which is a synonym. So this is the synonym replacement technique. Similarly, in the second one, you are inserting a word funniness, which is kind of taken from the context of the document and added to or augmented to the final document. And you also have random swap or random deletion of words, and all these things are done with some probability. So you have some probability to factor in, which will make your augmentation techniques better. More complicated techniques such as hypernym replacement, where things like bread pudding are replaced by baked goods dish. So this is the first technique, rule based, and now Vivek will explain the later techniques.
So in contrast to rule-based techniques, model that use a predefined rubric to generate augmented data, model-based techniques make use of language models such as BERT to generate augmented data. So these language models learn contextual representations of text, and these representations can be learned either using a generic corpus and then be fine-tuned for a more downstream task. Building on these learned representations using state-of-the-art language models, we aim to initially experiment with two types of techniques. The first of these techniques is scent augment. This approach aims to learn task-specific query embeddings and then uses these embeddings to retrieve sentences from a large corpus. Our hypothesis is that such a technique could be a very efficient way for query reformulation, given the availability of large click-through data sets such as ORCUS. Moving on to the next technique, that's called InParse. Multiple experiments have shown that using domain-specific data for training often leads to better results. This work proposes a few-shot learning-based augmentation technique using the online version of the Curie version of GPT-3 model. Although the authors have encouraging results in this paper, the cost associated with this model is still high because it takes around $5.85 to generate augmented data for 1,000 query document pairs using the Curie version of GPT-3. So what we want to do here is use a freely available version of GPT, such as GPT-J, for our experimentation. Next on, moving to the test design. In all our experiments, we would be evaluating our models based on two metrics, mean reciprocal rank and mean average precision. As we are fine-tuning re-rankers, we are currently experimenting with vanilla BERT. Moving on to the deployment models. So we aim for the data augmentation module to be deployed as an independent module. We also wish to integrate this module to existing IR frameworks such as FlexNewArt. And finally, we'll be shipping the module as an open source Python package that can be downloaded and installed using pip. Moving on to the risks and challenges. So these are the risks and challenges that we have currently identified. The first is difficulty in adoption. This can be fixed by ensuring seamless integration into existing IR frameworks. Further, as we want to make the module pluggable into multiple frameworks, we would want to analyze our current implementation and evaluate the feasibility of integration into other frameworks. And finally, we also want our model to be robust enough so that we do not sacrifice the performance on a given class or set of queries to improve performance on another subset of queries. Next, talking about the tools and dependencies, as we already discussed, we'll be using two datasets, MS Marco and Cranfield, and all our implementation will be done in Python using PyTorch. And for the baseline implementation, we'll be tapping code from the open repositories for the papers that we already discussed.
Let us now look at an overview of the general division of tasks in our plan. This has been split as general, which includes literature review, design, and plan, setting up of the data set, running the information retrieval model, performing rule-based and model-based data augmentation techniques, implementation of the query reformulation techniques, and finally, packaging the work as a pip installable package. Now we'll discuss the interface implementation for our integration with FlexNewArt. We have set up the integration with FlexNewArt where the required data augmentation module can be passed as an argument to the train script of FlexNewArt. And apart from this, we're also using some other parameters such as maximum number of validation queries and the number of epochs required for training. And this can be tuned based on the requirement. So what we've done here is that we've set up the baseline model, and the baseline model starts with training the re-ranker model with Vanilla Bird, and then in the FlexNewArt framework. And for the data set, we've used a subset of the MS Marco data set. And the data set size that we've considered is nearly 31,000 records with a validation set size of 500. And the metric that we've used is mean average precision. So while we were training our baseline model, we noticed that the entire training converged at nearly 5 epochs, and therefore we have continued to use 5 epochs for our training of the experiments as well. For the experiments, we've worked on random character insertion and word insertion, where a character is at a random position, a random character or a word sample from the set of characters is inserted. We also have random word delete, where a word at a random position is deleted. And we have random character replace, where at a random position, a character is replaced by another character or by a closest keyboard neighbor. And finally, we have random word swap, where with selected 2 random indexes, the 2 words are swapped in the document. So we've applied all of these techniques. And what we notice over here is that the baseline is at 0.3445. And on the application of our techniques, we noticed that random word insert gave nearly the same accuracy. However, the other techniques did not perform as well. So what we've done, what we hypothesized at this point of time is that with the addition of the data augmentation modules, the convergence did not happen at 5 epochs as per what we expected. And therefore, we hypothesized that with the extension of the number of epochs, we would be able to get better results. In addition, we also noticed that data augmentation modules have probabilities associated with them. The probabilities include the number of records being passed into the number of trained records being passed to the data augmentation module, as well as the word and character level probabilities. And we believe that tuning these parameters would also help us achieve better results. So moving on to our progress on the milestone plan. In our spring semester, we have completed the entire literature survey and developed the design of the data augmentation modules, set up the baseline, and after coding the rule-based modules, have integrated this into FlexNewArt. And we have run all our experiments to see how the data augmentation modules are working. In the fall semester, what we will be doing is that we'll be extending the rule-based techniques to make them work in unison with each other, and also extend this to model-based techniques for data augmentation and query reformulation techniques. And we'll apply this to both document as well as query, and then build the Python package based on that. So as for our reflection, the extensive literature review, the design document and the plan document helped us clearly define our goals. And since we've already defined the interface of integration with FlexNewArt, this will help us in the future because it will help us build other techniques that can be easily integrated into the framework. And on looking at the results, we believe that the augmentation modules would work better once we tune the augmentation probabilities, as well as if multiple of them is used in conjunction. And also, if we do use a richer model-based technique, we believe that the data augmentation would be learned better.
Yeah, floor is open for Q&A. So it looks like you guys have made good progress. I'd be happy to hear from the advisor as well. At the end of the day, who's going to use this?
My comment if yeah, so the advisor is speaking. So in the end of the day, practitioners are going to be using this. What is interesting about data augmentation is that it's very commonly used in audio and image computer vision pipelines. You basically you can't train any model that doesn't it heavily relies on these data augmentations, and apparently these augmentations they don't work really well for natural language. The good question is why. So it's so basically it's a sort of a burning research question how to make them work. And yeah, so in the end benefit of this is that people could train better models, and data augmentation is particularly important for people who don't have a lot of data, which is basically everybody. So that recent approach, like in parse that was cited, it looks like really really promising, but I think that there should be some complementary, some benefits of combining simpler augmentation techniques with more complicated ones. Yeah, that was sort of all for me.
So what, I guess I totally understand why you're using the fixed data sets with Marcos and the others, right? But then I guess why I was asking who would use it is there seems to be then like this jump that it then becomes this Python package that anyone can use. And what happens when we then are, training it on a new set?
Well, actually, I do have a user of some. Well, it is obviously useful for educational purposes, but I actually have a real user who used the models that I implemented before, and they were doing literature survey. And with literature survey, you could use Google Scholar, of course, and other. I think they're using Google Scholar and Semantic Scholar to pull these abstracts. They have a query. The query is big. They do all like kind of, and then they pull everything together. But in the end of the day, it's still like a lot of work to go manually through this list of abstracts. So they really do need some sort of reduction in processing time. And if you have in-domain data, you can train your model to re-rank these abstracts, and that's going to be better than just using BIM25 on abstracts. But you will never have a lot of queries. So you will maybe annotate 200 queries, and then when so the hypothesis is that for these people who are doing this, little scale information retrieval like enterprise search, literature survey, and et cetera, et cetera. So for them, data augmentation should be a much more important technique to use than say for Google. Does it answer your question?
Yeah, it was. Yes, I can see a lot of uses actually for this in some of the work that I'm working on. And I actually wrote down that imparse link because I'm going to look that one up.
Yeah, so there are a lot of things to try, and the model-based techniques, of course, are super interesting. Well, one thing that I would love to see us doing, MS Marco comes with two large query sets, and one query set is like smallish, only a few 100,000 queries, but another one is gigantic, which is like 20 million, and there is a connection between them. So you basically can train connection that there is this co-click information. So basically, if you know that if two queries are similar and they user clicked on the same document, these queries are related. So in my sort of dream, one of the byproduct of this is like train a seek-to-seek model that uses this information and supervised and using back translation too, and we'll get like a really nice query formulation model that you can poke, and that could possibly produce queries that are like very human-like. So, and that could be useful for something as well, maybe if not directly for improving performance, but maybe for something else too. Yeah. And within parse, it's indeed a good question, like how efficiently this can be done. And they also within parse, one problem within parse is the way they do it. They actually don't train in parse on in-domain data. Which is interesting why they're not doing this. They're training it on MS Marco. They train a huge model. They annotate a lot of queries using this super expensive GPT. They train something like 5 billion parameter model to rank documents. And then they transfer it to another collection and they say, oh, transfer works okay. But my feeling is that transfers are not always working well. And we need to be able to train this sort of to demonstrate that this works, the augmentation technique itself can work cheaply and efficiently on in-domain data. So that would be an interesting question to answer.
Okay, yeah, it looks good, guys. Yeah, I actually have some some things I need to think about with this, because I think I could use some of the stuff with things that I'm doing with building some domain information within specific educational domains.
Yeah, awesome. So it would be actually nice to, again, I have some ideas about how this like more sort of less supervised approach than in parse to try, because in parse you still they bootstrap it from MS Marco, but MS Marco is research only. If you want to deploy something like you have a startup, right? People kind of use it for the startup, and like Hugging Face, they have a huge repository, but this is really gray area. You can get, if you get caught and you use MS Marco in production, there may be fines and lawsuits, and you probably want to avoid this. So you probably want to train your domain specific models without bootstrapping and without transferring from data sets that are prohibited to be used commercially, if this makes sense.
Yeah, sure. So do you think you'll get there to where you're training in this project on additional data sets?
Well, this is the MCDS project. It should have a relatively small scope. We should try simple things, and even if they don't work, we ask a valid research question, right? When we started, I didn't know if augmentations would work or not. There are actually some other techniques to try. Maybe it will, and what will work, right? So we need to ask this little research question. This is a course project, right? So this is not a study by a PhD student. But what I was able to do in the past to some degree of success, and I hope to continue with that. Once something of that is working, you can do some extra work and either publish a paper or write some additional code or produce a good run on the leaderboard. So something that is obviously an extension, but it is typically like all of that is unrealistic to expect, in my opinion, within like a single MCDS course. Yeah. So this is just, yeah.
All right, you have lower expectations. I see you got like 5 people for 24 units in the fall. That's a PhD right there.
Well, maybe we need to ramp up a little bit.
Don't underestimate these guys.
Okay.
All right, no, that's good. That's all I have.